We could start. Okay, we'll have people come in. Thank you for joining. For those of you who don't know me, I'm Abid Patwa. I'm with the Department of Energy and the Office of High Energy Physics. I'm the program manager for the Energy Frontier program at DOE. So I'd like to thank you for joining us in our this week-long PI meetings that we have. We usually do this every year. Try to give you some guidance on what we're doing in the program, and then also try to help you for mainly the universities who apply from year to year for either of our FOA, no problem, for FOA, or either our comparative review FOAs or the early career FOA. So I'll give some guidance. Also, any of those of you who are from the lab also can see, because of course the early career is open to both the universities and the labs. So let me begin. Let's see. Okay, so basically what I wanted to get at was just give you an overview of the program, HEP program, some planning and budgets. Then I'll get into the Energy Frontier program. Then you may have heard a version of this from Bill Kilgore, who's the program official for the comparative review process in our office for the university one. Some remarks on what to look out for the early career research program, and some closing remarks. One of the things is I will try to, where I can, emphasize the Energy Frontier program in the context of, and that's mainly the LHC and the Future Particle Collider program that is managed under the Energy Frontier umbrella. But overall, in the broader context, in the overall HEP program. And then also I will try to give you some plan overview of the FY23 HEP comparative review FOA that we're working on right now. One key issue here is that please make sure that to look at the announcement when it comes out, because there's always some fine tweaks that we do in these FOAs. We try to keep most of it the same from prior years, but there's always some tweaks that either we do because we've learned from our past years, or even the Office of Science recommends it to be incorporated in future FOAs. Okay, to begin on the HEP program, one of the key items here is that DOE is a mission-driven agency. And one of the aspects about, especially the high energy physics program, but across all the Office of Science programs, is as far as the mission is concerned, we are from the early phases of any initiative that we take on, we plan it, we design it, we do the R&D, we actually go and build and fabricate the experiments and the facilities that are associated with it. We start operating it, and then of course, we see the science there. And then we continuously do that. And of course, we're here this week at Snowmass as part of the planning process for the long range future. Of course, you know the mission is to discover, probe, and explore the basic nature of space and time. But as how we do both of these is that we make significant contributions to the global facilities and experiments. For example, the LHC at CMS and Atlas, in Cosmic Frontier, Rubin, and LSST. This includes the project managements and under the DOE project system. Also, the science collaboration in all the stages, we support them in all stages to lead to the science results. We support the technology R&D on accelerators and detectors. And of course, we form interagency partnerships. We have for the LHC program, as you know, with NSF, also with astrophysics and Cosmic Frontier with NSF, and NASA with also in Cosmic Frontier. Now, within the US HEP efforts, DOE, of course, supports around something on the order of 80 to 85% of the overall efforts. Of course, NSF, NASA, and other agencies like that support the other aspects of it. And then, of course, we have program guidance. We have something you hear in multiple times. We have things known as the FACA panels. This is the Federal Advisory Committee Act. And these are the official advisory bodies to the US government. A good example is the HEPAP panel that advises, that's the primary advice to us from DOE and NSF. And then also there are sub-panels underneath this black, is that we have sub-panels under HEPAP. And what you've heard two, of course, this week, there's been several in the past, the ongoing international benchmarking studies that are happening, that's a sub-panel under HEPAP. And of course, there's P5. Now, this is how our office is structured. We have two divisions under, of course, we just had Jim Segrist, who is our associate director for high energy physics. Harriet Kung, as you heard this past Sunday, is the acting director. There's a search ongoing right now. We have two divisions, is the research and technology division and the facility division. And under that is that we have these different boxes, but in red, I highlight what is the primary for Energy Frontier. This is the research component. Then there's the LHC operations component. This is for the detector operations for Atlas and CMS. And then you have the projects, the actual critical decision projects that you hear about. This is the high luminosity, the phase 2 upgrades for Atlas and CMS, and then the high luminosity accelerator upgrade project. And of course, there's several cross-cut efforts, a general accelerator R&D that supports Energy Frontier, detector R&D. There's of course computational HEP, and theory of course is big. And then of course, much of our program is based offshore. And so there's the international agreements program that are there. But one of these are the three primary. For those of you who, when we discuss grants and scientific staff funding at the laboratories, the funding comes out of this box right here. And then of course, the funding for Atlas and CMS operations is there from the operations program here. And then the upgrades are there. I'll get into more of these details a bit later. Okay, let me give you a brief overview of the budgets. Many of you know this, but the way our fiscal year planning begins is, of course, the president submits what is known as a PBR, a president's budget request for the next fiscal year over. Though that usually comes out around the spring time frame, around February. Sometimes if it's late, it comes around in April. It's usually near the time frame of the State of the Union address. And that's the request that he submits, he or she submits to Congress. Then each house submit their own version of what's a draft budget. They're known as marks. So there's a Senate mark and a House mark. For the next fiscal year, which is expected to begin in October, on October 1st for 2023, we are here right now. We have a House mark. We're waiting for the Senate mark to come out. Now, at that point, both houses have to agree on a single bill. It's a process known as reconciliation. There's no amendments allowed beyond this point. They want to make sure that the process converges. And then Congress passes the legislation. The president must sign it, and then it becomes law. Now, one of the things is if this process doesn't complete by the end of a fiscal year, Congress has a couple of options, right? They could pass a continuing resolution, which is known as a CR, or if they do not make any action, then parts of the government will shut down. And we've seen that in past fiscal years. That basically we do not have authorization to spend until something is done by Congress, either a CR or you actually get a budget. Okay, so what Harriet Kung showed this slide here. This goes back to 10 years, FY12, all the way to what we have enacted right now. You have the key elements in green. You have the research, what we normally call quote unquote research. They're composed of these elements here. And then you have a slice here, which is the SBIR. If you were to look at the legend, we have a small business and innovation research office there that's across all the offices of science. And the blue is the operations for facilities operations. The red is what are known as the major items of equipment. These are the project world, is the high luminosity upgrades, for example, are in the red. And then you have the line item construction, the large projects here, LBNF, Dune, Mu2E, and PIP2. These are the line item constructions. I want to focus, so this is how it's been growing. As you note here, what we've enacted is a little less than 1.1 billion. The request that came out earlier this year for FY23 by the president was a little over 1.1 billion, and the House mark is above that. And so you do, in 23, it is slightly growing. A lot of it is driven here, but there's also some initiatives that are growing inside here. So if I take the green, and the yellow is always there. This is the SBIR. But if you take the green and slice it into different components here, the green in this plot is what we know as the core research. And then you see here, all again, going up inactive, there are some Office of Science initiatives. These are administration initiatives that have been coming out for the past few years, and they have been driving the growth. One of the things to see is this is the core research program. This is what was envisioned by P5 in 2014. That's the program that that many of you are familiar with: Energy Frontier, Intensity Frontier, Cosmic, Theory, Accelerator, Detector R&D. You see, it's been decreasing, and the overall budget has been growing, but it's been driven by some of these initiatives. Some of these initiatives I list here, of course, is that there's the dedicated AI ML initiative. There's a new initiative that started just this fiscal year, advanced computing, and it grew up to 4 million almost. 2 million went to Energy Frontier. Another 2 million was distributed mostly to Intensity Frontier, but also Accelerator, R&D, and Theory. But the 2 million to Energy Frontier was done to offset some of that reduction, and it went to the laboratories. It was meant to drive some of the HPC workflows, the code development for our use on HPCs, and try to set up at the laboratories, our DOE laboratories, the network and the infrastructure that is needed to really advance some of these computing initiatives that many of you on CMS and Atlas are very familiar with. And so that was split, but partially it was done to offset these types of reduction. It wasn't a large reduction, but that helped fund several. There's a lot of computer specialists at the labs, and that helped. There's also the microelectronics initiative, and so this has been done to help offset some of the reductions that you see here in core research. We could get back to it in the discussion if you have any questions on this. Okay, let me get into the Energy Frontier program. Many of you know this already because you're here at Snowmass and all familiar with the 5 science drivers that were described in the last P5, the 2014 P5, and of course we still use. We still use the frontiers, the Energy Frontier, Intensity Frontier, and Cosmic Frontier, mainly for budget process because it helps distinguish the different elements of our program portfolio. But 3 out of the 5 science drivers are in Energy Frontier, but you see that there are multiple frontiers that address each of these science drivers. And of course, that has been done intentionally by the framers of the last P5 is to ensure the cross checks of our results. The portfolio that is supported in high energy physics, of course, the main one is Atlas and CMS. And there have been some dedicated support for some modest support for ILC in Japan. Of course, we are waiting guidance from the Japanese on how they want to move forward on the ILC. There's been some R&D and physics studies that have been done. One of the things that I constantly, and I continue from the previous slide because of the pressures on the research budget, and many of you have priorities to ensure that we deliver our commitments to the upgrades, the Atlas and CMS high luminosity upgrades. It's been difficult to try to come up with new initiatives in Energy Frontier given that budget. But I have in the past few years, I have stressed that if you do work on the LHC, you can, applies to both the universities and the laboratories, up to 25% of your time. That we feel does not impact the LHC work at that level. You could work on studies for concepts of future colliders, and also even including the Snowmass studies that in the past couple of years you've been working on. We are the largest single collaborating nation in the Atlas and CMS experiments. I list the fractions here, and basically the distribution of labs and universities across the 2 experiments. Our nuclear physics office supports the heavy ion research at the ELISE experiments, CMS and Atlas, and NSF also, you've heard from Jim Schenk, this earlier this week is on LHCb, CMS, and Atlas. So we are in a very, very nice timeline. We've come out of COVID and the pandemic and this shutdown. It was meant for 2 years. It did extend due to the pandemic for a third year, and we are now are starting to collide beams at CERN on the LHC. And of course, there's a long-term program. It is meant to go, if you look at the CERN schedules, it is meant, there will be other shutdowns that take place here after LS3 to continue some of the maintenance work and that's needed for the experiments and the accelerator complex. But of course, we are now starting run 3. And of course, there's the long shutdown 3, which will allow us to start installing the components of the accelerator upgrade and the detector upgrades. But there's, of course, as one of the P5 science drivers is to really study the Higgs. And of course, LHC will be the only place for at least the next decade or two to actually really study the Higgs down to a few percent levels and even look at some other types of decays. This is the di-Higgs production decay that is extrapolated during the high luminosity era. And of course, there's a larger discovery potential for new physics during the run 4 era and beyond. So I mentioned the Detector Operations Program. This was under the facilities box. And the Detector Operations Program basically supports 3 main components. Of course, is the program management for the operations program. Then what is known as the M&O, the maintenance and operations of our detectors. That when we built these detector subsystems, we have to maintain and operate them at CERN, at the experiments. And then also a key driver is the software and computing. So of course, the tier 1s, one is at Fermilab for CMS, the other one is at Brookhaven for Atlas, and the NSF colleagues support the tier 2 computing facilities at the universities. But also the computing hardware, the core software, tools and provision, everything that is needed to support and get the physics out. And of course, our Oscar colleagues, the advanced science computing research colleagues in that office, support the ESNet transatlantic network capability to get the data transferred from the tier 0s to the US tier 1s. One of the key initiatives we started is in 2017. It came out of an operations program review, was to start developing the software and computing framework for the high luminosity era. And that's a key part of this operations program. It does get reviewed every 2 years approximately. The last review was just this past early February, for both the US Atlas and CMS. And of course, all the resources we coordinate with all the other funding agencies and CERN itself through what is known as the Resource Review Board that meets at least twice a year. Now, the other is I mentioned about the computing initiative, and one of the drivers is that we're trying to come up with solutions, cost-effective solutions, to try to really control the cost and get the data out, both collected and analyzed during the high luminosity era. So we realized a few years ago that if we kept the initial system that was developed for computing and also the software, the costs start for both, disk storage, CPU, they start growing. And we called it a $1 billion problem because if you do a back of the envelope calculation, you start noticing that, you soon start realizing that you don't have sufficient funds to actually keep it going. The operations program annually is somewhere on the order of $50 to $51 million in the budget. It's split by Atlas and CMS, but that's approximately what you have. And of course, you need to sustain that. So of course, we've been working with the experiments, with also the high energy physics field to try to find synergistic approaches and to really try to control the cost and in some sense, develop the computing infrastructure and the software to fit some more realistic profiles. We were trying to leverage HPC usage, really trying to understand when we give funding, what is the optimum balance between CPU, disk, and the networking. And of course, there's been some R&D investments that are being made to try to really understand that and try to get a technical design report out by the experiments to really understand what will take place when to try to control these costs and still keep the detectors running. Of course, there's a software foundation a few years ago submitted a framework paper to try to understand the strategy. And since then, the experiments have done very nice progress to several documents that have come. And we keep pushing to try to get, this is coordinated between DOE and NSF very nicely, and the experiments also, CMS and Atlas, to try to come up with the framework so we could begin run 4 and beyond. Okay, so the upgrades, I won't get it. Many of you know this. I have one from CMS and Atlas. So when the projects, right before the projects began in 2016, there were elements that were carved up to try to make sure that we have our expertise in the US and try to deliver on the different components. The ones that are marked in pink here are those that have been that are from the US side, the DOE and NSF. And of course, for Atlas, similarly, we've carved up different elements of the detectors, the DOE scope that's listed here, and also the NSF scope, which focuses on triggering aspects at higher luminosities for the high lumi era. And of course, these are carved out. I do want to mention one thing here is that I've said it consistently, and I've said it to PIs. I know many of you who are supported from DOE on the base program are doing the NSF scope, either on Atlas or CMS. That's perfectly fine. When I have to make decisions, I make sure that you are doing US scope. And when I say US, it means DOE or NSF. Of course, at the end, if there is a priority that I have to take because of limited budgets, I have to try to make sure our DOE scope is not impacted. But then I do try to discuss with the NSF colleagues to try to ensure that we don't impact any elements of the NSF. And we've been trying year by year to ensure that. Now, let me just give you where we are as far as the project. So DOE also has contributions to the Accelerator upgrade project to supply the quadrupole magnets at the 2 different collision points for Atlas and CMS areas. One of the key is in our DOE project framework, we have these milestones. The first one is what is known as the CD0 or the critical decision 0. It's a mission need. It's a statement that we put together at DOE that there is a gap in a capability gap to try to fill that gap in the process of needing a project that once it's completed. And that's actually what initiates the DOE project. And so for both this upgrade and the Atlas and CMS upgrades, these are 3 projects at DOE, separate projects, but that initiated the project back in April. And then since April, we've had in different years, we've had different milestones, a critical decision 1 and a 3A. A 3A is certain items that need long lead times to get the procurement going. So for the magnets, the superconducting, the conductor that was needed, the actual wire to purchase it and start building these, that was done in October. And then we had a CD2 and a 3B in February. The 2 is a very key milestone. It's the project baselining. So basically here at CD1 time, there's always a cost range for the projects. And then at CD2, we come up with the actual cost. And once CD2 is there, Congress, when they pass a bill, they try to make sure when we get the funding that we have to dedicate funding at that any project that's beyond CD2, we try to make sure that that fits in our overall budget. It's given priority, in other words. And so that was done right a year before COVID, of course. And then they also achieved right at the end of December 2020 a CD3 for full production. Now, we also signed an MOU between CERN and Fermilab on our contributions to AUP. That was done in March of last year. Now, one of the things is, of course, we've gone through COVID, and there's been schedule updates by CERN, especially on the long shutdown 3. And we are aiming to re-baseline this project. It's meant to be for fiscal 23, so sometime later this calendar year. The review has not been scheduled yet, but we are trying to do that, re-baseline it to try to take that into account and also into account the pandemic, impacts from the pandemic. On the Atlas and CMS, similarly, we went through different milestones for CD1 for the 2 experiments and also have done CD3A for different elements to get some of the procurement going in that sense. The key here is the project baseline is being planned for this fall for both Atlas and CMS. And that's on schedule. And again, is to take into account the LS3 schedules and also the COVID impacts. And of course, there is a MREFC project, a major research equipment and facilities construction that the NSF had. They had a series of conceptual design reviews, preliminary design reviews, and a final design review right before COVID. And then they did get approval, authorization from the National Science Board in 2020. And now they've officially become an MREFC project. And they are also planning to rebaseline due to try to understand some of these schedules and COVID impacts. Okay, one of the things is when you submit a proposal, what key elements, most of these proposals are from Atlas and CMS, what really is needed in the research narrative when you provide elements of that? It's of course, the funding comes out of the research program. So one of the key elements is to make sure that you do discuss the research program. Not just the end game of the physics analysis, the publication, but everything from ground up. If you are able to do it, we encourage you to do it. Object ID, performance, even triggers, and all the calibration and reconstruction that you're working on. And then one of the things that there's 2 components of these reviews. We review the proposal and we review the investigator. Investigator being defined as someone who is tenured or tenure track. And that's part of the comparative review process. And so basically we do stress that you discuss the output, your impact and accomplishments. Make sure you update your CVs or bio sketches that accompany the proposal. And of course, we really want, the idea is what should DOE invest in the future. So we really, of course, we're now past LS2. So I know we are completing some of the analysis that still exists, but really what is coming up in the Run 3 program. What I normally mention is the other parts also. It's usually balanced. So you don't have to always 100% of your narrative discuss your research, because you are also part of the upgrades. Even though you're getting project funding, your salaries are supported from the research program when we do it. So of course, ensure, and then over the next 5 years, there's the phase 2 upgrades, and we want to make, and you should discuss your contributions, not only to these the upgrades, but also to the operations program if you have operations elements. You do not have to do all 3. I know if you're a single investigator, you could do 2 out of the 3, or if you are doing all 3, yes, then you do have to provide that. You should provide that narrative, but we try to understand the balance to make sure that the review committee does not say you're too overcommitted as a single investigator. That's usually what we get from time to time. One of the things is, as I pointed out, please do keep the scope aligned with what the previous couple of slides that I showed on Atlas and CMS to make sure that we are delivering our aspects of the upgrades. The other, of course, is there's a very nice center LPC at Fermilab. Also, the 4 Atlas labs have what are known as the Atlas centers. You do not always have to be at CERN. If you can make use of resources if you're on CMS at Fermilab, if you're on Atlas at the other 4 lab centers, do discuss that you are coordinating and collaborating with the other labs in that aspect. You're not required. It does sell well that you are working with your other colleagues in the US in that sense. So please do stress that in the proposal. I do want to talk, we're at Snowmass. We're planning, of course, the future of this program. Of course, HLOHC is a key aspect of the future, but also trying to really understand the long-term future in how Energy Frontier will evolve. If you go back to the 2014 P5, they stressed 2 aspects when it came to colliders. One was, of course, there's a recommendation on the ILC to try to support some of the development and also collaborate with Japan to try to see if we could get the ILC moving. but also to really look at very high energy proton-proton colliders. So basically a hadron type of machine was stressed in the 2014. So do some of the R&D for that. Now, keep in mind, these are, you've seen from Tom Roser's slides and also Vladimir's slides yesterday, these are very expensive machines. They're in the billions. And for a funding agency, we have to start controlling. We have to try to fit those types of costs into our budgets, or and work with Congress, and also on the executive side, the Office of Management and Budget. But not only that, we have to work with other agencies in the U.S. government, because these are very large. They're very complex. One of the agencies we work with is the State Department. They've seen these large infrastructure projects. There's the science and technology component of the State Department, and they have been pushing. They've been very excited about high energy physics, because it has all the elements. Not just, it has science and technology diplomacy. It has the R&D components to drive the technology, both on the accelerators and detectors. They're very large. They like to understand the governance, whether we are, whatever is proposed, if it's offshore, whether we are observers or member states, and they really like to see that. The White House Office of Science and Technology Policy is another element, and we've been working, both Jim Segrist and I have been, for the last 5 or 6 years, been active to try to advance these two elements within the other agencies in Washington, because of how large they are, to try to ensure global coordination. And so we've been pushing on the ILC in Japan and the proposed FCC in that context of the 2014. We've been working closely with what is known as the International Development Team, the IDT, which is composed of scientists. This was formed in 2020 by ICFA on trying to understand the next phases of the ILC in Japan. And we've also made it very clear to both the IDT and to Japan that if there are future intergovernmental meetings, to try to push the ILC and trying to get it hosted, hopefully in Japan, we definitely will be part of those discussions. Also in 2020, following the European strategy, both DOE and CERN did sign an agreement to participate in the feasibility study for the FCC. And that this is basically the study that is now ongoing, CERN and all the European partners, all the Asian partners, and of course, from the DOE side here. And again, I want to stress here is that this doesn't mean that we are just committed to these two. Of course, we know other aspects are being proposed here. It's just because that's the existing plan right now. Of course, the next P5 will come up. But I do want to stress again, you are able to commit up to 25% of funds, and you could do that. That's at your discretion. Of course, we've seen what's coming out of Snowmass. I've been observing the last few days, and of course, talking to many of the conveners in the past year or so. And of course, the next P5 process will start this fall. And so let's see what type of proposed future colliders, how this goes, the concepts, and also the technology R&D. Okay, let me, how are we doing in time? Okay, so let me quickly go through some of the comparative review elements. I won't go through, these are fairly heavy slides in the sense of FOA, what's in the FOA, but I will simply try to focus for those of you who are doing energy frontier proposals to try to guide you on what to pay attention to. But again, keep in mind, I just want to give you an element of why we do comparative reviews. We started them 10 years ago. Of course, if you look back, the next one will mark the 12th year if you do the math. But also note that the labs also do get reviewed. The Energy Frontier, because of the pandemic, it got delayed somewhat this time. The Energy Frontier lab review is scheduled for September for the Atlas and CMS labs. That panel is coming together now. But we have something, if you remember, I mentioned FACA panels. So we have HEPAP. We have something underneath HEPAP is known as the Committee of Visitors. The Committee of Visitors actually reviews us program managers. It's from the field. They're selected through HEPAP, and they come every 3 or 4 years, and they actually try to understand if we program managers are doing the proper job to try to not only advance the program that we are been assigned to, but whether we have all, we're properly making decisions for comparative reviews, for early careers, for anything, right? Whether we have all the paperwork in order, everything. So in 2010, this was proposed to try to really push comparative reviews, because in the past, it was basically site visits. We discussed it at the end of the site visit. Okay, you'll get this, please submit a proposal. We'll, through our general solicitation that we have, we'll get it reviewed, but there was no comparisons. It was, and it was very difficult for sometimes new investigators to come in with that method. So we started it in taking that recommendation to use comparative reviews. It was reiterated that we continue that in 2013. And then since then, the latest one was in 2020 to continue it, but also continue and try to give you guidance as much as possible. And this week, for example, at PI meetings to try to give elements of the, and of course, we want to make sure we are supporting proposals that have the highest scientific impact and potential. So the next FOA, we're still working on it. I was told this morning that it is in our grants office. There is a draft. They are reviewing it, and it does take some time because it has to go through different offices at DOE headquarters and to our DOE Chicago office that actually makes the awards. So we don't have a date yet. I do not know. I'm hoping, I'm keeping my fingers crossed to try to get it issued by the late summer or maybe early fall. We try to give about 2 months, not exactly, but 2 months almost on that order to actually help you write the proposal and then submit it. So I don't have an exact date. It does support these 6 elements of the program. Letters of intent are not required. They're encouraged simply because that helps us plan some of the panelists who should be on the review that could give you that could really review your parts of what you're narrating in that. It's not, again, I already know many of those who are planning to renew this next fiscal year, but of course, I encourage you, if you can, get it out, a letter of intent to our office. And there's ways how to submit it is described in the FOA. And of course, depending on when we issue the FOA and the final date, the review process and also the actual awarding process will run into spring of next year. Sometimes we get delayed because of budgets. This year was very much delayed because we received the appropriation in March, late March, and trying to really try to then come up with the plan of what we fund and how we get these out the door. Just to help, there's a frequently asked questions is collected. Many of you ask a question we feel is yes, we didn't clarify in the FOA. We started adding it. This has grown to over some 60 questions over the years. It gives you a guide that if you ask a question, of course, one of your colleagues may have the same question but forgot to ask. We try to put this up on the webpage also to try to describe different elements of the program. So please do refer to those that when they come out this year. Now, there's been some updates. Many of you know these, but these have been updates over the past years. One key update that started back in, I think around 2016 or 2014, I forget, on the data management plan. Please do submit it. In the next slide, I will describe that a bit more. One of the things, if you do not have a data management plan for any research proposal, we have to decline it. If you submit it it cannot go into review. And if you submit it at the deadline, then yes, I apologize, but that is the thing. You cannot, because the deadline is over. So do keep it. It's very easy. I will let you know for Atlas and CMS, it's extremely easy, and so you should not be able to miss it. In the next slide, I'll get into that. Also, if you have a DOE grant and you are renewing, you have to submit what are known as renewal proposal products. These are the publications. You've been doing that every year when you submit an annual progress report to our office. You then, right after you submit, our system, PAMS, it sends you a notice by email and says, please submit your renewal proposal products. And you have about a week or 10 days to try to get it in. The key here is that if you do not get it in, we have no way of sending it out for review. So we try to urge you to try to get it in. And you are allowed, it basically copies and pastes everything from the previous years, and you could now update it. So if it was a submitted publication, now you can mark it as published if that is the case in that sense. And you could add more publications, for example. Anything that's public, Even conference notes that are public and on the Atlas and CMS web pages, you could actually add there, or even talks if they're public in that sense. Now, one of the key things that we've added, and I will get a little bit more later in the talk, is to try to understand your recruitment and mentoring plan. This is a key aspect that we are reviewing starting this last year and will continue into next year. I don't have much of this. This was initiated in FY18. Some of our reviewers pointed this out. NSF had some of this guidance in there for us. We extracted some of this. That if it's the same proposal in your, you do not address previous reviewer comments, and it's exactly the same, we do leave it to our discretion to try to mark it that, yeah, there was no substantial revisions, nothing was addressed, so we can decline it. I have not seen this for example, in Energy Frontier, but I do list it here. That's been there for the last few years. And remember, each FOA, regardless of what topic it is different, and eligibility, technical requirements, even the page limits. So I stress to read the FOA carefully before you submit. Data management plan. Yeah, so it came out in 2014. This is an Office of Science requirement. We work with OSTP to try to, and actually Atlas and CMS were the guinea pigs to try to develop this data management. They asked me, what do Atlas and CMS do? And actually they use that to try to push across the Office of Science what should be done. And so here's the answer. Basically, what you should do is 2 sentences in your data management plan and you're done. It's an appendix item. It's up to 2 pages you could submit, but you do not need to. You just say, I'm a collaborator on Atlas or I'm a collaborator on CMS. The experiment or the collaboration has a data management plan. And here's the link for CMS. Here's the link for Atlas. And that's it. I will put it into review, provided no other components are everything else is compliant in that sense. Okay, the other items to keep in mind, again, make sure everything reviews well. If it's aligned, of course, Atlas and CMS are aligned. You could also discuss future colliders, as I was pointing out, on some conceptual studies and also SNOMED studies that you participated in. That's perfectly fine. I actually encourage you to talk about SNOMED studies if you were active during these past years on SNOMED. One thing to note is generic research that's not carried out by any experimental collaboration. Usually depends on the topic, of course, and here is, if it's detector related, then you should submit to the detector R&D. But if it is for an explicit collider experiment, ILC, FCC, then yes, it would come to Energy Frontier for review. Again, keep the 4 requirements in mind when you're preparing and submitting a proposal. It's come down. We used to have over 10% of incoming proposals were declined. Now it's roughly, it's low. Last couple of years, I have not had to decline any Energy Frontier proposals. So that's really good. And also keep track that there's no personally identifiable information such as date of birth, social security number. Don't tell me what citizenship you are. It's not needed inside these proposals and in that sense. And also continue to work. I know many of you have to do this. I think all of you are required on the university side to work with your office, your administrative offices there to make sure the FOAs are met, and also the budgets, because many of you have to work. You come up with a budget and then you work with the sponsored research office to actually enter these and so make sure you work with them continuously throughout the process. Okay, I won't go too much into detail, but you could read this. I mean, again, we will try to keep the page limits there for 9 pages. But again, the key here is to develop, in the 9 pages, to develop a research plan of what you want to do. The rule of thumb is 1/3 on your past accomplishments and 2/3 on your future, or what you're trying to do. I mean, it's hard to, it's not exactly 1/3, but somewhere on that order, to try to keep that, because people want to know what your future, what you are planning. One of the things is you are encouraged to look at section 4 of the FOA. It does give you some idea of what aspects you should include in your narrative. And so to take a look at it, of course, I'm available before you submit. I cannot talk to you after you submit the proposal, but I could always talk to you before you submit a proposal, and you could ask questions and say, will this work well? Will this not work well? So just send me an email whenever you if you are planning on submitting a proposal any year. Okay, again, I won't get into too much. I do want to focus, many of you know what we support, but of course, please do read this part because of time. I do want to focus something about research scientists. In the next slide, I have some. One of the keys is that you are allowed to submit for support for research scientists. These are research scientists who have term positions. They're not tenured or tenure track. So they have special term positions, but it depends on, we have to look at these case by case. And I do ask the reviewers and the panelists to go through each research scientist to actually understand whether there's merits to support them on research. This is because you're using research dollars here. And really, you have to spell out whether their roles and responsibilities are well matched. If they're long-term on operations or projects, then we normally, because they're research scientists, we ask that they be funded on operations or projects, that you work with those managements to do that. But we try to, every year I do discuss with the operations and project managements, both before and after, sometimes mostly it's definitely after, because that was a requirement, a recommendation from an operations review that in 2019 that I work with these managements to make sure that these activities are not impacted if research support is coming. So I try to make sure to coordinate the different fractions of that, but do keep that in mind. Of course, you know what's not supported by HEP, and I pointed out we do not support heavy ion, and the HEP office, our nuclear physics colleagues do support heavy ion research. NSF, for example, supports gravity waves and LIGO, but those are not supported in our HEP activity. Okay, research scientists, there is a dedicated question and answer for the FAQ. You have two ways of trying to describe a research scientist. You could put that in your 9-page per senior investigator narrative. You're welcome, because that's open to you. You just have to fit it into the page limits. But we also have kept an appendix 2 narrative to really talk about the research scientist and what they are committing to. Again, the focus is on research, not projects and operations, to try to ensure research. And I get into what I mean by that here. One of the things is also they have a 1-page bio sketch, a CV, that should be attached if you're asking for support for a research scientist. And when I don't mean only the last elements of physics analysis, other aspects that a research scientist is doing. If they're doing any mentorship, please do discuss that. If they're looking at concepts for the future, or what type of detector elements or subsystems to develop, that's perfectly fine. That is what a research scientist should be doing in many ways, and that's perfectly fine that you list that. One of the things is research scientists sometimes are twice, sometimes 30–40% of times the salary of a postdoc. So reviewers do mention this, that, oh, because of constrained budgets, a postdoc could have done this. So try to really stress the long-term vision of what a research scientist is doing to ensure that we don't get this type of. There are excellent postdocs also. I do want to mention that can do this, but because of the salary difference and trying to fit that into the financial constraints that we see, we ask for this. Again, if it's long-term operations with very minimum physics research efforts, then there's a push by the review panel, work it out with the operations and projects to try to support them using those funds as well. Again, if it becomes a dominant activity, then that becomes a big issue. Okay, one component we have is, you saw the SC initiatives. AI/ML has helped a lot. Many of you, the labs know that you're getting AI/ML. If you're getting some of this, and when I do use AI/ML funds in university support, but you may not know that. You simply see the bottom line on your end, which is fine. But if you had machine learning components, I have requested funds from AI/ML to start putting some funds into to try to help you get a good grant, a sizable grant in that sense, and to try. Otherwise, you would see a reduced amount per fiscal year. So it's helped, and you guys have done an excellent job in trying to. To try to narrate this, and not just in physics analysis, but also on the trigger developments for the upgrades Computing aspects is also, there are two categories. One is, of course, you are developing these tools. And the other is you're just an end user, someone else has developed it, and then you throw in that, okay, I'm using machine learning or deep learning techniques. Of course, we really would like you to concentrate on category one here, and also tell us who's doing it, your students, postdocs, you yourself. Do describe the resources that you're committing to try to do some of these development. And they do review well, and they do tell us that, you know, this group is making use of AI ML, and then if I'm stressed with budgets, I do try to seek funds from the office to try to help you get a good grant here. And so I do give the same guidance to the review panelists, and they do provide some input when the merit reviews are out on that. We do encourage cross-cut and multi-thrust proposals. In fact, I give a very explicit guidance right at the beginning of a panel that we do encourage this. The key here is you have to make the case. Energy frontier, if you're doing Atlas and CMS, you're making the case that you're going to deliver the science on Atlas and CMS. The other aspect, if you're doing cosmic frontier effort there or an intensity frontier experiment, that gets reviewed in a separate panel, that aspect. But I do try to put some reviewers on my panel to try to, depending on what other aspect of the activity that you're doing, but you have to make the case on both. I've normally gotten case at Energy Frontier, they're delivering on Atlas and CMS. And then I asked my other coworkers on intensity, and they said, no, the reviewers didn't come out, or cosmic as well. So then we have an issue, right? So please do make the case. The reviewers back in I think this goes back to 2018 or so, they really wanted to understand how much you're committed, the person who's doing such an effort is committed to either energy or another area of the program. And so there's in the appendix, we do ask for a level of effort table, whether you're 40% on CMS, 60% on DESI, or in that sense, and your plan over the 3 years in that sense. And again, we really want to, there's a merit review question that does talk about this, and if it's reasonably developed and balanced. And of course, you can work with us, program managers, before you submit to let us know if you fall into these cases. Okay, this is the eye chart here, but these are the 5 merit reviews. There were 6. This is the plan right now for 23. We used to have a P5, whether they're aligned to the mission. If you see closely, this has been now put into, that sub-question has been put into the second criteria, but this is sort of what we are working. This is again only in draft right now. The final one will be known when it gets issued. But if you look closely at this 5th one here, is this new thing that we added. This was a 6th question last year, but now since we only have 5 questions, we want to keep it, and you can see what it addresses here. But I'll get into more guidance right here. So last year we introduced this question. It was basically to try to understand the recruitment and mentoring plan. Do read this. We want to ensure that we have a diverse, equitable, and inclusive research environment to try to understand you as PIs. How are you helping advance your group or even others in your experiment, if you are, towards advancing their career? That's the key. Now, so we dedicated for that question an appendix 9, the last appendix, or it's the second to last, sorry, a narrative for you to put. There's no page limit on that narrative, by the way. But of course, we do not want 100 pages coming in, but do keep in mind that we do, in addition to your 9-page research narrative, you could describe your efforts on that. Last year was the first time we've seen this. We got very mixed results. Many proposals simply pointed to, oh, we used the university hiring plan, some general platitudes they included, and the reviewers did not really understand. But we really want you to look at the sub-questions in the previous slide, and also some of these elements here when you develop it. It's how, if you also have postdocs who are mentoring other postdocs or other students, talk about that. If you have students that are mentoring others, collaborators, not only at the university, but other, when in these large experiments, do talk about that as well. And in that sense, we want more details than just, we followed the university hiring plan and we're aligned to the Department of Physics and Astronomy rules, and we want more than that in that sense. Also keep in mind, it's not limited to personnel that are currently on board or plan to be supported by a grant. You could also have a much more inclusive plan, because I know many of you are on large experiments. Some of you are based at CERN, or some of you travel to CERN and work with several collaborators there. And to talk about that, as well as the broader community in this narrative. And again, a large fraction of HEP research funding is devoted to students and postdocs. And we really want to understand the effectiveness of your support and your guidance to the personnel in your group and beyond. Okay, quickly, I just have 15 more minutes, but I do want to have a discussion. Let me quickly go. You see here what we do support. Again, do try to provide a compelling proposal for what you will try to accomplish in the next 3 to 4 years, but also give them a long-term vision of where you're headed. It always helps. You do not have to just restrict yourself. Of course, the key is what you want in the next project period, but give them some idea of the log, because as I pointed out, if you are doing Atlas and CMS, there's the program is supposed to run up to 2040 and beyond, or even 2041 is what the current schedule shows. To do discuss that. And I have made a very keen effort to try to bring in new faculty, new PIs with the DOE grant. Okay, let me go. I list here some aspects. One of the key aspects is what you should focus on. I give the same slide to the review panel. I don't adjust any words here. So I just want you to know that the other thing is we do look at program policy factors. These are to, again, to drive when we make decisions that are we paying attention to early career scientists? Are we providing, trying to encourage diversity, equity, and inclusion? And we make a key we use that to actually make our funding decisions, not just what came out of the merit reviews in that sense. Okay, there's a checklist here. I won't go through all of it, but in the opening pages of the FOA, we provide a checklist because there's all these elements that we want you. It's not meant to be everything here, but the main aspects do, again, look at the FOA for the guidance. There are other funding opportunities. Bill Kilgore provided some of these. These are open to you. Some actually have opened last week. And if you meet the eligibility requirements, we encourage you to apply. These are funds that come outside of the Office of High Energy Physics. It comes from what is the Workforce Development for Teachers and Scientists. I do want to give some slides on early career and just ask any few questions you have. So early career, I have 2 or 3 slides on early career, but I do want to point out that there is a plan to issue the next FOA. It's coming out, it usually comes out around the October timeframe for applications that are due early in the following year, around January or late January or February or so. And that is the plan. This is an Office of Science FOA. HEP is part of that. And one of the key aspects is to make sure you discuss some of the key challenges and problems that you are trying to solve. It's a 5-year funding. So try to provide a 5-year plan, but also, like I just said, give them a longer term vision of where you're headed in your program. And many discuss that because, oh, this will be used in high luminosity LHC, which is much more beyond 5 years, as you know. So do try to discuss that. So reviewers constantly ask us when we have panels, is it someone else doing it? It's a large collaboration. Just try to make sure that you are, when you're carrying out this funding, this research plan, why you have to do it. Try to, if you did some studies, simulation studies, some trigger efficiency studies, do describe that. And what unique capabilities are at your institutions. If you're a lab, if you have HPC or computing resources that you're going to leverage, please do that. If you have clean room facilities at either lab or universities, do provide that information. Even if you're a university and you have HPC capabilities and you're talking about computing and you're going to use that for some stuff, talk about that. That is a key aspect to try to push the proposal forward. What resources are needed? It's a 5-year timeline. So develop your budget profiles appropriately. You don't have to hit the bottom line for lab is I know $500K per year. If you're at 502.3K, that's fine. We figure that out. So, and if your university is 150K per year, I understand that. But if you don't have to say 150.000, if it comes to 164K or so, that's perfectly fine. But do give a profile to try to get your 5 years accomplished and what deliverables you're going to provide by the end of this 5 years. Again, your CV is really important. Do update your CV. They do look at it. They actually copy and paste it. They, meaning the reviewers, sometimes to try to explain whether there's a merit review question on leadership. It doesn't have to be leadership in just the experiment or the program. If you're doing leadership activities at your institution, your university, or lab, do talk about that, or even in the broader scientific community, do discuss that, because this is one aspect. Why are you a future leader? You could also write that in a narrative that you're carrying out these responsibilities. This is also listed in your bio sketch. Okay, for LHC, many of these proposals are LHC. The LHC proposals are somewhat balanced. They have some research component, and then they have something else, and that something else is either an upgrade element or a detector operations or a computing element. That's perfectly fine. Again, unique capabilities, be quantitative as much as possible. Whether you've done these studies, provide the plots if you can. Of course, there's page limits, and if you could fit these with figures and plots, please provide them. Innovation, one of the key reviewers this year pointed out one thing is that many of these these should be above and beyond what you see in either a comparative review proposal. Is there some innovation that you're doing that can really benefit the experiment? If you could talk about that, if you could provide quantitative measurements on that or studies, please do that. That's something that really does stand out. If you have AI ML to improve the current, using versus conventional methods, if you could do that, please do that. Again, it's a balanced program, again, and you're free to talk other than just physics in that sense. Many of these, of course, if you do new physics searches and you're trying to get, don't just state at the end that if after 5 years, I don't see a signal, I'm just going to set a limit. Try to give an idea of how to get to discovery. What would you change after if you got a null result in that sense? Reviewers would like to see both avenues of in that case. Budgets do matter, like I just said. Don't just come up, okay, it says 150 as the floor for university or 500 as the floor, K for labs. Do try to think about how you want to structure the budgets and what you want supported each year. And keep in mind, they have different eligibility. Don't just, if you are allowed to submit for universities, into the early career FOA and to the comparative review FOA, they have different page requirements you have to do, but keep in mind, it's different. The process is different. The comparative review FOA, most of those who look at it are from the energy frontier community. The early career, initially it starts out for reviewers are from the energy frontier community, but they're also cosmic intensity theorists, accelerator R&D, detector R&D specialists, expertise that look at it, and they should understand what you're trying to convey. So don't just put all these acronyms that no one outside the LHC community will not understand. So try to look at that. And again, mostly the FOA for comparative reviews, you give typically a 3 or 4 year grant. Here we ask for 5 years. So really need to understand that. One of the things is, this has worked very well. Try before you submit to give it to others in the community to actually critique. You don't have to take every suggestion that they give, but they have been through reviews in these past. They know what panels are looking for. They could give some guidance on how to improve. Okay, so let me end here we have 30 so far in Energy Frontier awardees, and since this program started in 2010, of course, this year we had 2 excellent. We had 13 excellent applications. 2 were awarded in Energy Frontier, Tova Holmes from University of Tennessee and Ben Nachman from Berkeley Lab. These are excellent, and I want to congratulate all of them for keeping this up. And of course, all of you who are planning to submit and who have already submitted. It's a very competitive program. And when I see these proposals, they are extremely well written, but it's just that little niche that's needed to try to get them up there. And the last year we had 4. That was the big year for Energy Frontier in this. Okay, I just want to flash what you should do, keep this, and what not to do. Keep this at your discretion, and make sure you could have these slides as reference and go through this and just see before you submit. Did I do that? Did I not do that? Think about it in that sense. Okay, and that's it. Again, I want to, there's very strong science coming out from our HEP program. Also, the technology, we're driving the technology, as I pointed out. That's one of the things that are, my work with State Department and trying to advance these colliders. They really do see that and they like to see that. Of course, we look forward to this SNOMAS study, the output here, and also the next P5 process for the next long-range plan. The FOA is not out. It will be available in these 2 websites here, so you could download those. I do want to stress, I know a lot of you spend time on your narrative, but also look at the justifications. One of the key comments I get from reviewers is they put this in the budget sheet. We have no idea what that means. What are they trying to spend on? And a lot of it comes from your sponsored research office or program office, but work with them and say we should provide a little bit more information on trying to explain what we're going to use those funds for. I do want to stress one thing. These are just budget indicators. I talked about the Senate and House marks. They're just indicators. Of course, only the budget is known when Congress passes an appropriation and the president signs it. So we will we're still working with our office to keep this program running and making sure we fill the priorities that have been identified by P5. Thank you. We have a few minutes for questions. Any urgent questions? Yeah. Let's see, Jason here.
Maybe something relative or relevant to SNOMAS. You mentioned about the 25% work on future colliders or detectors, and
yeah.
In past experience, what has worked well? Something that really is 25% where people are taking a big bite of some of these issues, or 10% where they're nibbling around the edges and not affecting too much their LHC work?
So yes, that's a very good question. So one key element is, of course, the key is the other 75 or up to is your LHC program. So the goal is not to impact those. So if I get someone on the panel says that, oh, they're working on all these other elements, but they're really not delivering on Atlas and CMS, then it becomes an issue, right? And I hear from the spokespersons, or I hear from some management at CERN, or not CERN usually, but the experiments management, that you have to keep that. The others is that, yes, a 10% activity, yes, we know, some people list it, some people don't in that sense, because what happens is 10%, we know no one is doing 100% to try to look at future of the field. Those have worked, some elements that I'm looking at that. If you do 25%, yeah, it's how much what you describe and what you're doing. Both work in many ways. Everyone we know is doing some 10%. So I would try to get closer to up to 25, provided you do not impact Atlas and CMS, because they really want to see, we do need to start looking at the future now, right? HLLHC is a high priority, LHC and HLLHC is a high priority, but we do need to start looking at the future, just like everyone is here this week, and the next P5 will also start looking at that. Anyone else? Yes, Roger.
Thank you. So Roger Russo, University of Minnesota, just a quick question. These large collaborations require management. management.
Yeah.
And so I never really get a feeling for what weight is given in the panels that I've not been on, what weight is given to people taking on mid-level management positions or having postdocs who are working at managing some part within the system. I mean, is this seen as being beneficial, or is this seen being,
Yeah.
how do we view that really?
Yeah, so there is many of this, I mean, especially in this area, right? In many ways, are there potential future leaders in the field, for example? We do talk, what I've learned talking to the experiment managements in the past, when this issue, not just for PIs, but for postdocs, and they have told me that they have, I do solicit input in saying that, okay, not during the review, but many have said in general that these are key. A postdoc is doing that type of activity in the experiment and the collaboration. That's a lot of work and all that. And so they have, it depends on the reviewers. If I get alternate guidance from the review, I do pose that question that, okay, the spokespeople have told me that this is a key element in that sense. We have to make sure that they're delivering on what they're delivering on, right? That's the key at the end. So we do want leaders in the field. So if they're doing management activities, that's fine. You should give some emphasis on what actually is going to get delivered after they finish in their management task.
Yeah, and what about for senior research scientists who are playing those management roles?
That's fine. That's fine. But if it's if it's project or operations, then we have the issue. If they're research, that's perfectly
So
fine. If you're on a physics group, that's perfectly fine. If it's coordinator role, that's fine too. Yeah.
Okay. I mean, essentially, I believe we should be encouraging people to do these things because these
Yes.
are really important if they're done properly.
Because it's needed in the experiment. And I hear it from the spokes whenever I talk to them over the years, they've also stressed this. Yeah.
If I may take, since I got the mic, may I take
No,
the
of course.
second opportunity? There's another on, I think your slide 9. You showed that the total budget was 312, 10 or so, if I remember correctly, million for the core. How much is for the university program, and how much is that goes to the labs, and how is that division decided?
So that's decided. So this 300 fits not just energy, of course. It fits intensity, cosmic, and and it depends on each program, right? Different frontiers have a different balance on universities. I mean, cosmic is heavily driven in the sense of lab funding but they also support universities. So the fraction is not 50-50. For energy, I could tell you from over the years, it's half and half. It's usually around 48-49% labs. After every fiscal year, I do the calculation. It's about in that order for labs, and they are around 51-52% university. That's an energy frontier, but it differs for each program. That's that's that. Harvey? Yep.
So actually,
sorry,
I have
go
a
ahead.
microphone up here. Yeah, sorry. One of the things that we've seen in Snowmass is that there's a lot of buzz about new colliders down to the future. You can be any one of those that you like, but all of them are extremely expensive. And even if you take the cost of the United States spending on particle physics, what Europe is spending, what the world is spending, it's going to require a paradigm shift or an increase in the amount of money that globally is spent on these projects.
Right.
I'm curious, what your perspective is of how we can, better lobby the DOE or the U.S. government, or to be able, because that's really going to be a key component. Despite all our best efforts, is we really need to somehow raise the threshold if we want those projects to succeed.
Right. So I mean, this is one of the aspects that will come out in P5. Normally, we give P5 budget guidance, and we try to give budget guidance so we could allow them, the P5 panel, to actually start fitting things in. But also we have to be somewhat realistic, right? In that sense. So I mean, right now, if you go to the previous slide here, you see the level of funding right now. It's above 1.1 billion. It's around that area. Now we are trying, and we give them guidance for the out years, and the question is this going to be 2 billion or is this going to be close to 1.4, around that. That's something that we are trying to work out now. P5 will see this. One of the things is, of course, as Harriet Kong presented in one of the opening slides and what the P5 addressed in 2014 in chapter 1, is that one country alone cannot fit everything. This is a globally collaborative program. And so one of the things that we will need to understand, whoever hosts a machine, is the international cost sharing. Because, you know, even if this was 2 billion, it will take some time, depending on the time frame for a collider, for a 7 or 10 billion collider. US alone cannot fit a 7 to 10 billion collider in that type of budget, unless something, yes, like you said, a paradigm shift. But we don't know that. So we do need to ensure that there are some, it takes time. It's international cost sharing discussions with different regions and countries don't just happen overnight. They take years, you know, trying to understand what scope they would provide from different countries to any collider that's hosted. We've seen this with the ILC right now, how long it takes for some of those discussions to transpire. So this is something that needs to be understood eventually. And it's done at the funding agency level, at the government level. But that is one thing that, and it does drive then the time when a project can begin in many ways, the international cost sharing. Yeah, I'll give Harvey and then, oh, he had his hand up, I don't know. And then Meenakshi and then Vaya or someone here, or Vaya.
Harvey Newman, Caltech. In a recent Committee of Visitors report, there was a strong recommendation to kind of restore the P5 guideline into core research. Yeah. But the profile that you showed shows a continuing decrease.
Right.
In fact, it's quite severe. If you think back 2014 before P5 and afterwards, since that time, now we have in the energy frontier at the LHC a double assignment, amazingly successful ongoing program,
right,
and the upgrade, and yet
yes,
the budget is shrinking, and therefore the manpower base
yes,
is shrinking, and this is a fundamental problem. So the question is, under the new management, is there hope for some rebalancing? Because there's no way to defend
yes,
that at a high level the program is optimized.
yes. So the short answer is yes. And what's happening is that Harriet Kong, for example, she and I were connected to a CMS, US CMS meeting. She's fully aware of these, and she mentioned one of the things is, of course, this will continue, these initiatives, but you're slowly seeing some stability here. But also one thing that we realize is that inflation is setting in, and you cannot, and not just in energy frontier, across in this green, right? And so we are working hard to try to, management is aware of this. It's just, if you go to the previous slide, these other aspects have to be balanced, and sometimes congressional guidance tells us exactly how to fit some of these other areas, right? And then when under a bottom line, and that's what ends up happening. But the short answer is yes, they are aware of this, and we're trying to fix this hopefully in 23, but since we're doing formulation right now on 24, we're trying on the agency side to try to fix this. Quickly, I know others are coming in for the next session. Go ahead, Meenakshi. Yes. Oh.
Okay, so I was going to ask a question on research. I'm going to skip that, but go back to the international cost sharing discussion, which was earlier. And there I want to understand, so if P5 gives the priority and then the DOE just has completely independent mandate of how to do these international cost sharing, or is there a community process there?
So we try to get, so we have, like for ILC, the discussions at the government level is going on cost sharing. We try to understand this because Japan has asked for, I'm just giving an example, but there is also the international development team that we try to work with, which is is an ICFA mandated team to try to help us, to guide us. So that's what the committee is, for example. So
But
in that sense.
there are what we share in, right, is it's important at
Yes.
what level. So what we, until now, at least the LHC,
Yeah.
if I take that as an example, the core cost accelerator and
Yes.
detectors,
Yes.
now it seems to be there's talk about different shifts into also civil construction and
Right.
stuff like that, which which is not part of the ILC, if I understand. Correct
Right.
me if I'm wrong. So are now the regions no longer responsible for their own infrastructure, or we are now opening it up for these colliders, and therefore in the LBNF dune excavation, others will chip in too? Is that the idea?
But that's exactly, I mean, if you talk about LBNF Dune, of course, we created it, the project, or even LHC. The sharing, of course, comes from those who are managing the infrastructure side, the scientists. They discuss with us, but they also are, I imagine, talking to their collaborators, not just in the US, but globally. And the experiments, there's also this coordination.
Yeah,
I mean,
yeah,
do you
there's a
have
paradigm shift. Sorry to interrupt you because it's short. I
Yeah.
understand the experiment and the other part, but the regions where,
Yes.
until my understanding is, nobody has done civil engineering in another country. So now if that is on the table,
Yeah.
then is that for not just the colliders, but for everything across all frontiers, because we have a big need in the excavation part right
Yes.
now.
Yes.
And is that being discussed? I haven't heard that during Snowmass.
No,
What
it
is the
has not.
process here?
That's a question for Snowmass and conveners. I mean, it's something that will come up definitely in P5 in that sense. And there will be town hall meetings in P5 where those discussions would take place. The previous P5, there were discussions in town hall meetings when those types of questions were posed. But that is the element. We could discuss further since I know many are coming for the next process. I know Vaya, you had, maybe we talk after. Yeah, in that sense. Yeah. Okay, thank you so much. I appreciate this.